So, of course, I want to start by saying thank you, everyone, for joining. My name is Cody Armstrong, and also on the line with us today is Neil Cook. Neil Cook is an expert in configurations, and we're very fortunate to have him with us here today. So, the topic, as you can see from the slide, is configurations in Onshape. This is newly released functionality, just as of last week, for configurations in Onshape, and we're going to walk through all of the details of using configurations. Now, we really encourage you, as always, with these webinars to ask any question that you would like. There's a questions section in the GoToWebinar control panel, and we will do our best to answer any and all questions that come up. So Neil is here explicitly to help us with questions. So really encourage you to ask any questions you'd like. We'd like to make these as interactive as we can. So use that questions section and go to the webinar control panel. Ask any questions that you'd like as we're going through things here today. Now, we're going to stick to configurations in Onshape, and I'd like to keep this as an introduction to configurations. Configurations is an area of Onshape with a lot of depth. It has a lot of capabilities, and we'll probably have follow-up webinars in the near future to go into some of the more advanced functionality that's possible with configurations. But I want to stick to the basics today to get everyone started using configurations and understanding kind of how our thought process was when we created it. So let's dig into it. Now, the agenda today is pretty straightforward. We're going to start with a simple introduction into configurations, what are configurations, and then discuss how Onshape configurations are different than what you may have used in the past. So if you have experience with SolidWorks or Inventor, some of the other CAD applications that have existed out there that have this kind of functionality, we want to get into detail about what's different about our approach. I'll start with a simple example, but then we'll get into more complex examples of the power of the configurations tool in Onshape as we get into it. Now, as always, feel free to ask any questions that you'd like. There's a question section there, and we'll do our best to answer the questions as we go through today's webinar. So that's a short list of the agenda. Now let's jump into the topic of the day, configurations. So if you're new to the concept of configurations, if you're asking yourself, what are configurations? You can think of them as variations of the design. So if you think of certain products, they have many different size variations. That's an excellent example of a configuration. If you think of a ball bearing, for instance, it has dozens of different sizes, roughly the same geometry. Those are excellent examples of configurations. The screenshot, the GIF that you see there of a pneumatic cylinder of different stroke and bore variations is an excellent example of configurations. It's a design that's meant to be built in different sizes. And those variations of the design are often referred to as configurations. Now, in the industry, this is referred to as a number of different things. I tried to round up some of the more common names that I've heard, but I know there are others. So part families is a common term that I've heard. Variants, another term that I've heard. Family tables, a way to use tables to drive all of these sizes. A design table is another technique that's commonly used in something like SolidWorks to drive configurations. So these are, kind of as a background, what are configurations? What are some names of configurations that have existed in past CAD applications? So that's a simple explanation as to what they are. I wanted to point out something that we've done a bit different, and this is something that initially takes a bit of getting used to, and I'm going to explain what I mean by that in just a minute, but in many old CAD systems, if you look at the SolidWorks or the Inventor, they're very much dependent on a table-based approach, we'll call it, where you're essentially listing every possible permutation as a row in a table. And, for a number of reasons, this can be particularly tedious, especially in highly configurable designs where you may have dozens of different things that are configurable and, dozens of different options for each thing that are configurable. And it's really not a practical answer for a lot of those kinds of highly configurable scenarios. But even in, a scenario where you have 800 possible combinations of product, that would equal 800 rows in some sort of table. And that's generally been the approach that has existed for quite a long time. So just keep in mind, this is what a lot of people are doing today when we talk about configurations. And it's one of the things that we hoped to solve in Onshape configurations, the ability to do this in a more intelligent manner. So what have we done different? One of the biggest things that I'll point out, I'm going to mention it in a number of different ways here today, is that in Onshape, you can configure inputs, right? Parameters for your configurations independently of one another. So if we get into scenarios where features, for instance, or dimensions, for instance, or independent, then you don't have to have a row for every possible combination in a giant table. And I will go over this in greater detail in just a bit. But in short, what I would say is oftentimes, and I would say the majority of the time, in Onshape, you're replacing potentially hundreds or even thousands of rows in a table with just a handful of variable inputs and maybe a list, right? Or combination of different independent inputs that accomplish the same thing, even an infinite number of different configurable ways to build your design, but without a table entry for each and every one of them. And I know if you've done that for a long time, that's something that can sound a bit scary, but I'll show you what I mean in just a bit, and I think it'll make a little bit more sense. Question: how do we keep track of configurations and metadata? How do we name the continued configurations automatically given the selections? And the answer will come up to that in just a bit later on in today's webinar. All right, so again, this is the key thing that I would stress about the configurations functionality, is that especially in highly configurable designs where you may have thousands of potential combinations, you don't have to have thousands of potential rows in a table entry to accomplish that. You can create a variable series of inputs that accomplish the same thing and even more with much less headache. Right. So that's the big thing that I would stress about our configuration approach in general, is that you can configure these inputs independent of one another and replace potentially lots and lots of rows of largely redundant values with these independently controlled inputs. So that's one of the biggest things that I would say is different about our approach versus what you may have seen in the past. Now, the question is going to come up, so I want to make sure to address it right up front. What about assembly configurations? And the answer is no, not yet. So question: what doesn't Onshape do in terms of configurations yet? Assembly configurations. So now there is a caveat to this. I will get to an example of it in just a bit, but if your design is in a part studio and then easily inserted into an assembly, as an example I'll show you, then it's very similar. But again, it's a multi-part studio. You're not creating configurations at the assembly level. And it's an important caveat that I want to get out of the way right up front, because I know it's a question that will come up often. All right, so let's get into our simple example of configurations. As I mentioned before, I really want to keep this as an introduction into using configurations and how to get started with them. So we're going to start with a simple pipe fitting example. So let's jump into it. I'd like to get into an example of configuring this part as a way to get started and show you kind of the basics of configuring features, defining what you want to configure, and so on. So let's start by configuring different values of this part, right, of this pipe fitting. And what I want to control are a few different diameter values, right? So I have an outside diameter value I want to control with configurations. I have an inside diameter value I want to control, and maybe I want to control this step value and a few other things. How would I go about doing that in Onshape? And what you'll notice is in the Part Studio, you have a tab here, little icon here for configuration panel. This is where you access all info related to building your configuration. So all your inputs, everything will be accessible via this configuration panel. So if I left click, it flies out, very similar to other flyouts that we have. For instance, the sheet metal table is a very similar kind of flyout. And you'll see I have the option to configure Part Studio. So I'm going to click Configure Part Studio, and what's going to happen is I get that initial list to start building out my configurations. And so, what I'd like to show you at first is, very similar to what you may have done in the past. And if you're the type that likes to have a one giant table for every possible permutation, and you just like the way that works, you can do that here. So I don't want to, to scare those that like that approach. You can just build one big table for every possible permutation, and it just be one giant list. So just keep that in mind as we go through things. And I'd like to start with that approach because I think a lot of users are comfortable with it. Question, are configurations compatible with sheet metal? Yes, of course. Fully compatible with sheet metal. And every other functionality, by the way, built into Onshape. So it should look and feel no differently than just about anything else. All right, so I've gotten into configurations in the configuration panel, right? I've chosen this option to create a new configuration. And you can see I've got default, and I can start to fill out values. And in this case, I can just type in names for different configurations. All right, so bear with me for a second, and I'll go through and fill out a few different configuration names. Now, let's make this 5.75 OD, okay? And so this is, again, very similar to what you might do in an old CAD system where, I'm literally just filling out individual names and then inputting parameters for each, right? So we'll say 6-inch OD, okay? And we'll say 1.75 ID, 6.25-inch OD. Right? So I've essentially listed 4 configurations that I want. And these are just names. I'm just simply typing in the names that I want for my configurations. And I've got, essentially I'm naming them by the values that I want the inside diameter and the outside diameter to be defined by. How you choose to define your configuration name is up to you. But after I've defined those names, I have to tell Onshape, well, what is it that I want to configure? So I've just given it a series of names, but I haven't associated those things with any values in the actual model, any parameters in the actual model. One thing I do before I get into that is notice at the very top of the feature list here, you're going to see all of the potential configurations, right? So as you're inserting those, you'll see those. And this is where you can access the various configurations without opening up the configuration panel. The configuration panel is really about building the configurations. If all you want to do is switch between configurations, you can do that in this drop-down. You'll see as you add things to your configuration list, they will be added up here on top of the feature list. So just a tip, if you do a lot of configuration work, you're going to be looking at this part of the screen quite a bit as you go between those various configurations. All right, so we've created 4 configurations. We've given them names, but we haven't really configured them to anything. And so what we want to do is configure the features and associate them with, some sort of parameter. Now, what's really cool about this is you can configure to just about anything. You can configure, dimensions, sketch dimensions, feature dimensions, right? Feature values, the end types, the sketch region selections, the selections in general, right? So combinations of points, for instance, I can choose different combinations. It's really just about everything that you can choose in the options, in the dialog, you can configure. So there's really not much that you can't do, and that's what makes this really unique. If I want to configure a dimension, I click Configure Features, I go click on that dimension. If I want to configure an extrude depth, I click Configure Feature, I go click on that extrude depth. It's really just click Configure Feature, click whatever it is that you want to configure. Again, it could be just about anything. So we mentioned before, I wanted to start with the inside diameter. I want to control the inside diameter with all of these various configurations. I will click Configure Feature, then go into the sketch. I'm just going to left click it here in the graphics and choose the dimension that I want to configure. Right? So in this case, this dimension here, left click, and it adds that dimension to my configuration panel. Right? So again, all I'm doing, click Configure Feature, go click on the thing that you want to configure. In this case, it's a sketch dimension, right? Make sure to click Done, and now you've configured that feature, right? So now you can go in and edit these values, right, and change them on a per configuration basis. That one doesn't need to change, but this one does. And so now I have 4 different inside diameter values for the 4 different configurations. And I can see that if I change the configuration here, you'll see that inside diameter value update and change, right? So that's really all it takes. You can click Configure Feature, go find a dimension that you want, left click on it, and it will be added to that, table, in this case, the list of values that you can then go in and edit. Again, very similar workflow if you've come from kind of the design table world where everything's a big table based on every possible combination. And so here I'm punching in, here's the value, explicitly defining the value for every possible configuration. I'm controlling all of that here. And I'm doing that, again, just by clicking configuration, configure feature and defining it. Now, as I mentioned before, I want to control more than just the inside diameter. I also want to control the outside diameter. And these two are closely related. In other words, if the inside diameter changes, gets bigger, for instance, I would expect the outside diameter, the large diameter here, to get bigger as well. In other words, the two should grow together. And it may not be perfectly linear. It may be that it grows incrementally based on some obscure kind of standard. And in those kinds of scenarios, those values are related. And that becomes important in just a moment. I'll describe why. But let's just say that I also want to configure the outside diameter. Again, I can go straight back to configure features. There's no restriction as to the number of things that you can configure in this list. And I can go to configure feature, go in and find the value I want. Again, I'm going to go into the sketch that controls the dimension that I want. You can see here's the outside diameter dimension. Left click, it adds it to the list. I'll click done. And now I'm controlling 2 different things in this list of configurations. So I can go in and change my values on a per configuration basis. Right. And so now, when I change configuration in the dropdown, right, I not only get a change in the inside diameter, I get a change in the outside diameter. And I'm explicitly defining what those values are. Right. Now, if this were just a simple offset of, it's always a given amount more, then I could design this in the sketch to be a bit more intelligent. But in many scenarios, they're not necessarily one-to-one. It may be that in certain sizes it's this, but in other sizes it's that. And they are related, but it's not a perfectly linear thing where all I can do is just add a simple dimension, right? It may be that the values vary from time to time. So this is an excellent example of a combination of things in a single, list. Now, again, as I mentioned, there's really not a limit to the number of things that you can configure. So I can go here, click configure feature, and go in and find some other value that I want to control. For instance, the boss diameter here, I can click on that and then choose a different boss diameter for the different values. Right. So I could easily come in and say, this should be 2, this should be 2.25, 2.25, 2.5, and 2.75. So now, again, just taking this to the next level, so to speak, I have 3 different configurable things that I'm controlling, each with their own independent values per configuration name. So just keep that in mind. I think this is the workflow that a lot of users are familiar with. If you have experience with configurations in past systems, I think this is going to feel familiar to you, where you're listing out every possible configuration name, and then you're just punching in values for every possible configuration name. All right, so let's talk about a few basics of working with these lists. What are the commonly asked questions? What if I wanted to duplicate a row? For instance, I have this, but I have another size that's very similar. I don't want to punch in all these values again. You can right-click. Another thing that you can do in the right-click menu is you can set one of these as your default configuration. Another thing that you can do in the right click is you can rename, you can move them up and down, and you can set one as the active. You can see the option there that says switch to and then the configuration name. If you right click in the table, you can choose switch to, and that will switch the configuration that you're looking at. Very valuable if you're in the configurations, editing them, and you don't want to go all the way over here to choose something different. All right, so right click menu, very valuable for accessing the move up, move down, delete rows, set as default, switch functionality. All of that's accessible via that right click menu. So that's an important part of working with these lists, right? The ability to manipulate them, because if I come back a month later and I realize we should have had a size between this size and this size, I'll want to insert it and move it up in the table in a way that makes sense to me. So that is a simple example of kind of a list format for building configurations. And if you wanted to, you can go through and build as many as you'd like in this list. So one good example of that, let's say that we have these 4 sizes, but we also have, a variation of each one of these sizes that has a 6-hole bolt pattern, right? So you can see in this example, there's a 4-hole bolt pattern, but we also offer, 4 different versions of these with a 6-hole bolt pattern and an 8-hole bolt pattern, right? How would we handle that type of scenario? And this is an excellent opportunity to kind of show some of the power of the way we've done things. If you think of, an old CAD system and how you would build, this in a table-based approach. Well, you have your 4-hole size, so now I need to build all variations for my 6-hole size. And I would literally, 6-hole, 1 point, 1 inch ID, and I would build every single size again. And you can copy and paste. There are techniques that you can do to, simplify this. But it left a lot to be desired. You were literally listing every possible permutation. And again, if you like this approach, certainly free to do that. But I'd like to point out what I think is, in many situations, a better way. So in this example, yes, I can go in and I can create every single, here you can see I've created the 6-hole variation of the first 2 sizes here. And I could go to configure feature, and I can go in and choose the hole pattern and say, okay, I want to control how many instances in this pattern in the actual list. You can see now I have 4. And in those bottom 2, I could choose, okay, we want 6, right? So if you like this table style layout, you certainly can do that. The list of configurable features is only going to grow, and the list of rows is only ever going to grow, but you have that flexibility. You can do that. And you can see if I make one of these active, now I have a 6-hole bolt pattern variation, right? Same exact dimensions as this one up here, but it has 6 holes instead of 4, right? And remember, this is, I have 4, 6, and 8 hole variations. Right? It's not just the 6, it's 8 and potentially more. And so you can think of, those examples where I have a configurable design with 4 configurable features, and within each configurable option is 10 options of themselves. And so you can start to do the math as to the number of rows and possible combinations. So what I'd like to propose is a different solution to consider. And that is using a combination of inputs rather than one big table. And again, I know that there are a lot of people that like the big table approach, and that's fine if that's what you want to do. You're certainly free to. But this has the potential to save you a tremendous amount of time. So let me give you an example. One tip that I found is you cannot delete an active row or column, active row. So make sure to switch in the table. Then you can go in and delete any rows that you want. So we're going to get rid of these 6-hole rows. We don't need them, and we don't need to control the hole pattern as part of this list. So I'm going to delete that column as well. So we're back to where we were just a moment ago. We're just controlling a series of values for each of these different configuration names. Now, as I mentioned before, and this is going to be an important part of using configurations in Onshape, is you have to ask yourself, what is independent? If I think of the bolt hole circle, the bolt hole pattern, let's call it, that's independent of every size. In other words, I offer a 4, 6, and 8 hole bolt pattern option in every size that we make. And in that scenario, the bolt hole pattern, the number of holes that you have, is totally independent of every other factor in your configurations. In other words, it doesn't make sense to create these redundant lists of all of these things when in reality it should be in every potential option, right? And that's an excellent example where multiple inputs make more sense, right? I have a 4, 6, and 8 hole pattern in every combination that we offer, and so there's no point in building a table entry for every possible combination when I can have in Onshape multiple inputs, right? So you'll see at the very bottom here this option to add a configuration input. This, in my opinion, is one of the biggest things in configurations in a very long time. You don't have to go through the effort of building all of those potential combinations. So in this case, as I mentioned before, I want to not only have the option to define my 4 different sizes that I have it listed in that list, I also want to be able to choose from 4, 6, and 8 options, right? So I can choose one of 3 different inputs. Now, a list is what we have here at the top. That's a list of all potential options. We also have 2 other options that are worth mentioning, checkbox and configuration variable. I'm going to show you an example of both of those in just a bit. But we're going to start with another simple list, right? And essentially what I want is 3 options in my list, 4, 6, and 8, right? So 4 holes, 6 holes, and 8 holes. So we're going to go ahead and do that. We're going to say 4 bolt holes, right? 6 bolt holes, and 8. Right? So now I've typed in, those are the 3 potential combinations. Now this input is independent with this input, right? Now what I want to do is I want to configure the number of instances in the circular pattern that generates this bolt circle. So again, just like I did before, I'll click Configure Feature. I'll go to the hole pattern feature that controls that number, go into the actual instance count, and select that as the thing that I want to control with this, right? I'll click Done. And now I've inserted that hole pattern instance count as the thing that I want to control. And now I can go into each and set them independently, right? So again, now I have 2 places to establish what I want to control, right? I have my initial size, but also independent controls of separate inputs, right? So this is something that, again, you can do the math very quickly, how many combinations of rows that you would need to accomplish this. And if I add another input, which I certainly can, you can have as many as you'd like, it only gets more and more, the list of rows only gets longer and longer, right? Now, one tip that I have is as you add more and more inputs, the names, it can help to rename them. Right, so the names may not be terribly descriptive. You can see mine's called list input 2. But if I click the ellipsis, the 3 dots here on the top right, I have the option to rename, and I can call this bolt hole number. Right, so just giving it something more descriptive, something that helps if someone else opens this and they're wondering what these things do. But that's an example of adding an input outside of the original. Now, a lot of users will only ever do this, and that's fine. Building out that table is just fine, but as you get to more and more possible combinations, these are solutions that can really make a world of difference. You can imagine, we've only done 4 here, but if you had 40? What if you had 40 different combinations of this flange, and then you had, 8 different potential bolt hole options, and then you had all these different combinations? It can get into the thousands. So independent inputs is probably one of the biggest things that I would stress as you're getting into it. I know there are a lot of users that like the tables, that's fine, but consider this multiple input option. And as I mentioned before, you can have as many inputs as you like. So I can say, well, what if I also want variations that don't have this recessed face? right? What if I want to build, a whole new, version of this design in all of the sizes, but it doesn't have this face. This face is one flush face, so to speak. I can create another input, and this might be an example where I'd create a checkbox input. Checkbox input is great for like suppressing and unsuppressing, um, going back and forth between two different values, suppressing and unsuppressing being the most common that I can think of. So if I wanted to just have a checkbox option that said, is this on or off? This feature that I'm controlling, whatever it may be. And this is an excellent example. The checkbox input is an excellent example where I'd use it. And we'll just call this checkbox input recessed face. You can define whether you want it on or off by default. And then you just hit the green check. Right? And what happens is now I have a third input controlling this pipe fitting. And now I can determine, okay, I want to control the suppression state of this raised face feature, right? So again, I'll go to click configure feature. I'll click on the feature I want to configure. And at the very bottom, you'll have this option for unsuppressed, right? So I can choose unsuppressed, and it's going to add that suppression or unsuppression state as the checkbox options in this example. I can click done, and I can uncheck when the value is unchecked and check when it is, and that will uncheck or suppress and unsuppress the feature depending on the selection, the checkbox, whether it's active or not, right? So now, if I check recessed face, you can see that recessed face disappears. If I check it again, it reappears. Right? Subtle difference, but it's a small cut in the face that again would require me to build an entirely new set of table entries for every possible combination that are now included recessed faces. So just keep in mind again, this is an option I think more applicable to the highly configurable designs, but the question that I would ask yourself is, what is truly independent in my design? In other words, the inside diameter and the outside diameter of this pipe flange are very much related. As I change the inside diameter, the outside diameter should go to some other value. It's probably, in this example, dictated by a standard or something like that. But they are related, and it makes sense to put them together in a list. But things like the bolt hole number and the recessed face option, those are options that we have throughout the entire span of configurations. And in those scenarios, it's perfectly acceptable to have them as separate inputs. It far simplifies the table that you would have to create otherwise, right? So just something to consider. I know there are a lot of users out there that have done things a certain way for a long time, but I think that's one of the biggest advantages to using something like Onshape configurations. All right, so I want to take this into the simple example and try and make it a little bit more real life, right? As we get into more complex designs, they're often more than one part, and they're often multiple things that you'd want to control. And for this example, I'd like to bring up the configurable cylinder. And one of the reasons I like to bring this up is I stressed at the beginning that we do not have configurations at the assembly level. But you can see in this case, this is a configurable pneumatic cylinder that's 100% defined in the part studio. It's only 9 parts, so it's a relatively simple cylinder, but all parts within it are defined in the single part studio. And this is an excellent example where I can configure all things in this cylinder based on changing just a couple of values. And a lot of this, admittedly, is how you design it, right? A lot of that is top-down, multi-part, which we're not going to get into, kind of top-down design techniques. But assuming that you've built your multi-part design in an intelligent way that behaves well when you make dimension, simple changes, you can very easily take your multi-part design, like in this example, and build infinite number of configurations for it. So remember, the first example was just a simple part, but in Onshape we can design multiple parts together, and with those multiple parts we can really do some powerful things at the part studio level. Again, pointing out we don't yet have it at the assembly level, but for a lot of users that are working in the multi-part environment, this is an excellent solution. Now, this also allows me to introduce the concept of a configuration variable. So in the last few examples, I showed you how we can generate a list and how we can use checkboxes to control, the different values and features and suppression states and so on. But what configuration values allow you to do is essentially have a variable that gives you infinite number of configurations. You can punch in whatever value fits your criteria that you specify, and it will build that size on the fly. And so the reason I bring up a pneumatic cylinder is it's an excellent example of something that's highly configurable. If you think of pneumatic cylinder, there may be hundreds of different stroke variations and dozens of different bore variations and port position options and rod clevis options and all these kinds of different potential configurable scenarios that just make the whole table approach really impractical. Thousands and thousands of rows to maintain all these potential combinations. So this is an excellent example where especially something like the stroke, where I have hundreds of possible combinations, it may be better just to have an open-ended configuration variable where the user can punch in whatever value they want and it builds that configuration automatically on the fly. And it just means that you don't have to go in and have an individual entry for each new stroke variation or each new bore size. So let me explain what I mean by this. This configurable cylinder is controlled by a few key dimensions. There's a bore dimension in the very first sketch. There's an extrude value that controls the overall stroke. And there's a port position transform that kind of. So there's a few key features that I'd want to control with configurations. But as I mentioned before, there could be hundreds of stroke variations. So rather than building a giant list, I would rather do something like create a configuration variable, right? So I can create a configuration variable. We'll call this configuration variable bore. Now you have options for configuration variables. So you can define variables as angles, integers, reals, text. So if you want to only allow certain inputs based on the type of thing that you're controlling, you can do that. But then it's just a matter of defining what it is, what's your default, what's your minimum, what's your maximum, right? So let's say that in this example, my default bore is 6, right? And my minimum bore is 4. And the maximum bore size that I want to allow in my variable input is 12. Right? So I'm defining a default and a min and max range of acceptable values for my input. So I hit the green check OK, and now I've created a variable input for bore, right? So you'll see it here on the left side, and it'll pop up over here on the configuration panel. And so from there, I have that control, right? I have that input defined. Now, if we think about a pneumatic cylinder, the bore and the stroke, at least in our scenario, let's say, are really independent of one another. In other words, I may have an infinite number of stroke variations in the 4-inch bore and the 5-inch bore and the 6-inch bore. So they're not really related. They're independent in that sense. And so it's another example where the stroke in this example is going to be a separate input from the bore, right? So I'm going to create another configuration variable called stroke, right? And I'm going to define, let's say, a default of 18, a minimum of 12, and a maximum of, let's say, 48, right? So I've defined two variable inputs. Variable inputs, you can punch in anything that you would like here, right? You can see those are my two variable inputs. Now, what I'd also like to do in this example is control where these ports are located. And if you look at this model, there are 4 potential places on the faces of these end caps to place those ports. And so what I want to do is allow the person configuring this to choose from one of those 4 options. Right, this is another example where I'd use a list. So configuration variables are great when you want an infinite number of potential options. Bore and stroke are a good example of that. But if you want to choose from a given list of options, then you'll need something like a list, like we showed earlier. So list, it's just a matter of giving the different positions, right? And so in this case, we're going to say the 0 degree position, then the 90-degree position, 180-degree position, and so on. So I'm listing out each potential combination or each potential option that I want to choose from for this input. And again, remember, this input, the position of the port, is totally independent of the bore, the stroke. So we have these combination of port options in every combination of bore and stroke, and that's why it's configured independently. But you can see I have 0 degree, 90 degree, and 180, 270. Those are the 4 various positions that I would want to configure. So I've laid out essentially, here are the 3 things that are important to me. And if you do the math, let's say that I had 10 different bore variations and 20 different stroke variations and 4 different positions for the port. It's 800 rows in a table. But in this case, it's going to be 1 configuration variable, 1 configuration variable, and a list. Right? So far simplifying things. And you can use combinations. If your design dictates 2 lists, that makes sense in your design, that's great, right? It's easier than building one very big one. So the ability to control them independently is, again, pretty powerful. So how would I do this? Now, in the case of configuration variables, you can see they're not configured. One easy way to configure them is just to go into the sketch, right-click, and you'll see the option to configure in the right-click menu. And I didn't mention this earlier, but you can also do this, instead of the configure feature in a number of different places. But the right-click menu option is an easy way to configure dimensions or values, whatever it is that you're trying to do. And by the way, another question that comes up is, how do you unconfigure? Same right-click. If you right-click something that's currently configured, you will see it's then set to unconfigured. You'll have the option to unconfigure. All right, so in this case, I want to set this to the bore. You can see this is the configuration variable that we created just a moment ago. So I'm going to choose bore, hit the green check, and now this configuration variable for bore controls the diameter of the bore in this cylinder. Right? So if we change this to 5, or if I change it to 4, now I can change this on the fly to any value that I punch in this configuration variable. Do the same thing for the stroke. I can go into the extrude feature that controls it, right-click the depth in the extrude feature, and you'll see the option set to stroke. Right? So I can set that to the stroke, and now the depth of the extrude, which controls the stroke, of course, is controlled by the value that I punch in. Right? So I could punch in 24, and now I have 24-inch stroke. I could punch in 36, now I have a 36-inch stroke. And so I can build any kind of combination of these things on the fly without manually creating a table entry for every single potential combination of them. So these are only 3, but if you imagine, if I have a dozen or more different things to control, then that quickly becomes an issue. Okay, so last thing I want to mention about this is controlling the transform. Here's an example where I could just click configure feature, right, go into the transform, and control the angle of rotation that controls the port's position. Now, I will say this requires you to set up your port in an intelligent way. So just keep that in mind. There's still some design intent necessary to build around the concept of configurations and configurable designs, and building your design in a configurable way is something that's pretty much universal in any CAD system. But in this case, what I have is essentially a transform that locates the port on the 4 different positions. And all I'm going to control is that angle value for the 4 different positions, right? So I can click done, and now I have 0 degree, which should be 0, right? 90 degree, which should be 90. 180 should be 180, and of course 270 should be 270. And now I can set where this port is just by choosing the different positions, right? 90 degree position, we'll rotate that port around to the other side. Right? You can see there, rotates the port around to the other side. I can go to 180, all right, rotate this thing around, and there's it on the 180 side, and 270. So now choosing where the port exits on this cylinder, a very common thing in this kind of scenario, can be done with just a drop-down option with the 4 potential combinations that I created. And again, remember, I can choose not only the 4 potential port positions, but any bore and stroke size variations that I want. All right, so we've discussed just briefly the kind of simple getting started, and I've also gone into the multiple inputs. I think that's a lot of where the power of this comes into play. And you may be asking yourself, well, you've built all of these configurations. How do we actually use them in drawings, and how do we actually use them in assemblies and so on? And the answer, this is one of the unique things about Onshape, is you can do this in a very intelligent way. So let me explain what I mean. Is in the assembly, in the drawing, you can choose and even generate new configurations on the fly. So in the insert dialog, and when you're inserting in the assembly or when you're inserting into the drawing, you're going to see anything that has a configurable design. So as I expand out here, you're going to see the different configuration options. This is that flange that we were working with just a moment ago. And I can choose, okay, I want a 1 1/4 with a 6-bolt hole and a recessed face, and I hit generate. It will then build that configuration on the fly, and I can insert it, right? So you don't have to open up the pipe fitting, add a new configuration to a table, and then come in and insert it into the assembly or the drawing. You can build that right here in the insert dialog. Now, in the example I gave you a moment ago, let's jump back into the configurable cylinder here, and we'll delete. And what I want to do, show you that you can build all of these things. So the configuration variables that allow me to define bore and stroke very quickly, just by punching in values, can also be punched in on the assembly level. So let's say, for instance, that I'm in an assembly and I have a need for a 5-inch bore, 22-inch stroke pneumatic cylinder, right? I can go in, that configuration doesn't yet exist, right? But I can go in and say, okay, I want a 5-inch bore, 22-inch stroke. Let's put it at a 90-degree port position, hit generate, and it's going to build that configuration on the fly for me. So now there is a 5-inch bore, 22-inch stroke cylinder in my assembly. Now, I can do that without having to open up independently and edit a table independently. So I can control all of those inputs as I insert. And that's another big advantage to having it built this way. If you have a big list, yes, you can choose from a very long list, but you can imagine scrolling through a huge list here can be somewhat tedious. So again, you can do this as you're inserting into the assembly. You could do this as you're inserting into the drawing. That's another important aspect of this. So you can build configurations right on the fly from the insert and then drop drawing views into your drawing without having to open it up first. And it's one of the biggest benefits. So that's to answer the question, how do we take these configured part studios and bring them into the assembly and the drawing? You'll see the option in the insert. You'll need to expand out the part studio, but you should see those same configuration inputs as options, allowing you to build them on the fly. All right, so that is my spiel, so to speak, on configurations. And I wanted to jump back to my slide deck just briefly here and just to reiterate something. And I think it's an important thing to reiterate because it's relatively different than, it's quite a bit different than what you may have done in the past. And that is, when you're getting started with this, it's important to think about, what's independent. In my design, what features are independent from one another? What parameters could be sketch dimensions, any number of different things. But what is independent versus what's dependent on one another? So in the pipe fitting example, the inside diameter and the outside diameter are very much dependent on one another. When I change the inside diameter, make it bigger, I would expect the outside diameter to also get bigger. And, that value could vary, but it is related to the inside diameter. And in those scenarios, you would want to put them, they're dependent, you would want to put them in a list together. But if you answer the question, is this independent? Does this go across all different configurations? If the answer to that is yes, you can have a separate independent input to your configuration, and that can save you a tremendous amount of manual data entry into tables and so on. So that's the one thing that I would say is a bit different when you're getting started with the configurations. Ask yourself, what configurable parameters are independent from one another and which are related. And oftentimes you'll want to pair those related dependent features together, whereas the independent ones could be separate inputs. All right, so that's kind of a simple intro into our configurations in Onshape. Now, the next question that I want to answer that comes up quite often is, can you use feature script with configurations? And the answer is yes. In fact, this is one of the more powerful aspects of configurations is you can reach in and grab any parameter of custom features just as you can the extrude command or the revolve command or the native Onshape feature. So it's really not any different in how it behaves. So what I'd say to that is, some excellent examples that I've seen, the beams feature. The beams feature is one of the most popular custom features out there for building, kind of library standard profile sweeps, and it's great for those structural builds and things like that. And oftentimes you want to configure things like the beam size or different elements of the, different ways that it merges and so on. You can do all that. Another example, like the screenshot that you see there on the left, a port block. There's a custom port feature available publicly, and you can customize and build your own configurable port block based on that port feature and configurations. So just realize you can combine feature script and configurations, and you can control feature script parameter, your custom feature parameters via configurations in a very easy to use way. And there's more to it than this. This is when we start getting into some of the more advanced topics that I want to steer past for now. But there's all kinds of very cool potential for part parameter. You can pull in derived parts with all these different parameters and automatically via features with all kinds of very cool stuff that you can do. But I just want to stress, main thing to take away here, yes, you can use configurations to control custom features. Give you a quick example of this. Let's go into the cartridge valve body here. In this example, I have a port feature you can see here that is in my design, and I've already built a few of the different sizes that I want. So I have a 10 and a 12 size for the 3 different size valve blocks that I want. But as you can see, as I switch to these different valve block sizes, my port feature stays the same. What I want is for this port feature to change as my valve block size changes, right? So just as I would any other feature, I would go to Configure Feature, choose the feature I want to configure, in this case, the custom port feature, and choose the parameter that I want to control, right? In this case, the port option, right? I can click Done, and now in the list, on the far right of my list of configurable features, I have that port size, and I can choose something else for the different sizes, right? So now, on a per configuration basis, I'm choosing different size ports, right? And again, the port feature is a custom feature, right? It's available to anyone, but it is not an Onshape feature. It's a custom written feature. It's an example where the configurations are really treated no differently than anything else, in the sense that you can go in and use custom features just like you can use extrude depth or revolve values or any of the native Onshape features. All right, so that is using custom features and configurations, right? So custom features written using feature script, yes, you can configure them. All right, so I have just a few minutes left. I have a few things that I want to discuss, a few last final things to kind of wrap things up here. I know the question has been asked quite a few times. I've been saving it for the end, and that is configured part properties. How do we manage the metadata associated with all of these configurations? It's important to stress this is an area that's going to change very soon. Hopefully very soon, we're going to have a little bit better way of handling this. But I do want to show you how this works today and then what we hope to add in the near future. So you can configure part properties, right? So at the top of the configuration panel, you have this configured part properties option. And essentially, you go in and you add the properties that you want to configure. So you choose the property that you want. And there's a list there: part number, material, appearance, description, vendor, project, product line, title, and so on. You choose the properties that you want to configure, and then you punch in the values for them. So in the case of like part number and description, for instance, you would type in the part number and description. Now, I know the question is going to be asked. In fact, I think it already has. Can you automatically generate things like part numbers and descriptions based on other values? And the answer is no, not today. We recognize the need for that. We recognize why that's important. We recognize how important it is. So we're working on it, and we'll hopefully have an answer to that very soon. But just realize today, if you're typing in part number, description, those kinds of things, they are simple text strings. There's no way to intelligently link them as of today. But just realize that's one of the biggest limitations. We're aware of it, and we're working on it. So what does this look like today? If you go into a document with configurations, at the very top of the configuration panel, you're going to see configured part properties. Right? And so for here, I can choose add property, and I choose the property that I want. In this case, we'll choose part number, for instance. And it's going to go through and add a part number. And I can say, for each possible combination, here is part number. Right? I'm going to go to the next one. We'll say PN 1298, and so on. So I can lay out the combinations and the part numbers that go with them. Now, of course, as I mentioned before, these are just text strings, right? They're not intelligently linked to anything related to input parameters, but that's something that we're working on. Now, the reason you would do this, the reason this is so important is things like the bill of materials and notes and things like that, and the drawing and so on. So yes, it's important to keep in mind if you do, something like this, and you link to a note, it will pull in those parameters, right? So if I choose the 10 size, you can see, as I mentioned before, in the insert, you can choose the configuration, and then I can go in with a note and link it, to something like the part number that we specified. You could see there's my PN 1098. So you do get the linked part properties based on the configuration that you choose. The thing that we're working on, the thing we hope to have very soon, is the ability to intelligently populate those things in a way that's that's a little bit faster. So that is what I had planned. I have two final things that I want to show you. I mentioned earlier I wanted to keep this simple and kind of focus on the core things that you need to know to build the basics of configurations. But there is some really neat stuff that you can do here that I wanted to point out. And both of these examples were created by Neil, and they're excellent examples of some of the things that you can do. That's not immediately obvious, but very, very powerful. And one of them is this pipe fitting example. And the reason I bring this up, and this is just a teaser for those that are wanting to attend that advanced configurations webinar in the future, you could do all kinds of really neat things with configuration. So one example that I like to point out that Neil did in this is he laid out every possible combination in this standard for the various pipe fitting options. And there is many of them, because in this example, there are pressure ratings for all these different sizes. So you have 150, 300 pound. And for every one of these different pressure ratings, there are different dimension values, and for every one of those different sizes. So a half inch has 4 or 5 different potential combinations. A 3/4 inch has 4 or 5 different potential combinations. And then within those, you also have the slip-on weld neck options, the blind options. So this is an example where the amount of rows would be daunting in a table, because you think of, the differences between every single size has a 150, a 300, a 400, a 600, a 900. And building that out would be very, very tedious. What he's done in this example is he's used an array of values. So if we look closely at the value here, it's actually an array of different values for each pressure rating, right? And so by choosing a different one in the list, you're pulling up a different value in the array from that list. And that's, if you think about every potential option having 5 combinations, and then you have, all the different combinations of sizes, the list would be very big, right, of rows. But in this example, I'm just using an array of each potential combination and calling up each value within the array by the various pressure ratings. Very cool stuff, and something that is, really pretty unique. Another example that gets asked, I believe it's already been asked. If it hasn't already, forgive me. You can do things like expressions and the values. So in this example, he's using the length configuration variable to determine what the diameter of the shaft should be. If the length configuration variable is bigger than 150 millimeters, then the shaft diameter should be 1.5 inch. Otherwise, it's 30 millimeters. Now, this is cool for a number of different reasons. It's an if statement, right? So I'm saying if this is bigger than this, then set to this. It also shows that we can work really well with multiple unit styles, right? 1.5 inch, 30 millimeters in the same table. That's something that has, in many other CAD systems, caused a whole world of headache, but in Onshape, it's very easily dealt with. But it's an excellent example where, if I change the shaft diameter to something bigger than 150, let's change it to 175, if I change the shaft length to something bigger than 150, the actual shaft diameter will change to accommodate for it, right? Because of this simple statement in the dialog. So these are all excellent examples of some of the cool stuff that you can do with configurations. I know we don't have tons of time to get into it now, so I apologize. I just wanted to show you just kind of, what's possible, what potential is out there if you're starting to get, into depth configurations. And we will be covering these in greater details in the future. We will be having a more advanced configurations webinar that discusses this and many other different things, configurations related, in the future, so stay tuned for that. All right, so that is what I had planned. Both Neil and myself are going to stick around and answer any questions that you have. So again, feel free to ask any questions in the questions section there. Forgive me for running just a little bit long. If you want to stick around and answer any question or ask any questions, feel free. One last thing I would mention is if you're interested in learning more about Onshape, if you're just getting started with Onshape and are interested in learning how to use it, definitely check out the Onshape Learning Center. There's self-paced training, there's instructor-led training, technical briefings, lots of great content available, learning content to actually learn to use Onshape. So if you're relatively new and still getting the hang of things, definitely check out the Onshape Learning Center. So that is what I had planned. I want to say thank you again, everyone, for coming. Stick around if you have any additional questions, but otherwise, thank you and have a good day.